Hello, this is Geometry 8.4. We'll go over some proportionality theorems. So theorem 8.6, the triangle proportionality theorem states if a line is parallel to one side of a triangle and it intersects two other sides, then it divides those sides into proportions. So what I mean by that is if you look at the side lengths AD, CE, DB, and EB, those would all be in proportion. I would say the easier way to think about it is just to let each of the side lengths be single variables like X, Y, Z, and maybe like P. Then really the proportion is set up there for you. You just make each of these ratios and then set them equal to each other. So X over Y is equal to Z over P. I mean, technically you could write the length AD over CE is equal to DB over EB. Okay, that would also be a correct proportion. Another correct proportion is if you rotate the triangle 90 degrees counterclockwise. So I could also set up Z over X is equal to P over Y, because these two proportions really give you the same thing. And here's why. If you cross multiply, you get X times P, that would equal Y times Z. If I cross multiply here, this would be Y times Z is equal to X times P. So even though you might think these are different proportions, they're equivalent proportions. Okay, so I've written down the triangle proportionality theorem in words. A line, in this case DE, is parallel to a side of a triangle. In this case, DE is parallel to AC, and it intersects the other two sides of the triangle. So it divides these two sides, AB and BC, proportionally. And I have the proportions written down there. Okay. Theorem 8.7 is the converse of the triangle proportionality theorem. Since I wrote the triangle proportionality theorem in terms of a conditional statement or an if-then statement, I would say before I write it down, you should be able to write down the converse of the triangle proportionality theorem. If you came up with something similar to what I just wrote down, then that would be a correct converse. But basically, in terms of a diagram, here's what the converse of the triangle proportionality theorem states. So if you have a line that divides two sides of a triangle proportionally, so if I let this be like A, this segment right here, B, C, and D. So if the ratio of A to B is equal to C to D, then this line or segment is parallel to the third side. And I'm going to label that as far as, I'm going to let this be just XY and this be PQ. I'm going to label that as R as well. But then XY is parallel to PQ.